All right, welcome to AA 2.4, finding inverses algebraically and verifying them. Verifying them is one of the more important pieces of it, so make sure that you keep that part in mind as we move forward. So to start with, when we're referring to inverses, we're talking about operations that undo each other. So if I'm adding something and I want to get rid of that addition, then my inverse operation is subtraction. If I'm multiplying, it's division. Squaring, so that's to the power of 2, square root, is my inverse. And if I'm cubing, which is to the third power, then it's cube root, which is 3 in that little v part there, in that little check. And the way that I do that, there's a few different ways I can take the cube root of something. For example, if I want to take the cube root, wow, that was messy, of 8, nope, just kidding, cube root of 8. Goodness, I'm trying to figure out what multiplied by itself 3 times is going to give me 8, as opposed to just twice with the square root. In the calculator, what I can do is 8 to the power of 1 divided by 3. If I had the 4th root, it would be 1/4. If I had the 5th root, it'd be 1/5, so on and so forth. So some of you may not have seen that notation before. I just want to make sure you've seen it now. Also want to review real quick the order of operations. We start, anytime we're evaluating, we start with parentheses and grouping, then move to exponents, multiplication and division, and addition and subtraction. Now, when we are doing those top to bottom, that's when we are evaluating, or as we've used it recently, checking. Whoops. But when we are solving, we use the opposite direction. Solving or isolating, we go from bottom to top and use inverse operations. To undo, there we go, to undo each of those operations. Now, the exception that I want you to note with this multiplication division piece, let's say I have y equals 2x plus 6 over 10. If I'm solving that for x, for example, I'm going to treat this top part as though it's a group. So this fraction, that's a grouping symbol. So the first thing I'm going to get rid of, the only thing that I can get rid of here, is the 10. So I would multiply both sides by 10, and then I would start over in getting rid of the addition and then the multiplication. So you treat it like a group, get that part alone first, get the group alone, and then move on from there. Okay, so these are some lengthy notes. Finding inverses algebraically, the first thing we need to remember, f of x is the same thing as y. So anytime you're dealing with that, if it's got an f of x, same thing as y. Don't let it confuse you. Step 1 is going to be to switch x and y. And that's literally just put them in the opposite spots. So I'm going to have x equals -2 y plus 6 over 4. My next step is to solve for y. So what I need to do here, and I'm going to do some rewriting steps as I go forward, got, oh my gosh, got x equals -2y plus 6 over 4. So remember what I told you on the last slide was that -2y plus 6 is in little group. So what I need to get rid of first is the 4. So I'm going to multiply both sides by 4. So My next step then, I don't really need the parentheses on the left side, so that can just be 4x equals negative 2y plus 6, because those 4's divided out to 1. And then I can just go back to my, inverse operations and getting y alone. So next I'm going to subtract 6. Remember that 4x and negative 6 are not like terms, so instead of combining them or attempting to, I'm just going to write 4x minus 6 equals negative 2y. Next, I'm going to divide by negative 2. And I can do this two different ways. I can write this as y equals, because those divide out, 4x minus 6 over negative 2. I can write it that way. Or because in this case, and sometimes with inverses, it's just going to be easier to leave it not simplified. In this particular case, 4 is divisible by negative 2 and 6 is divisible by negative 2. So I can simplify this a little bit more to be, negative 2x plus 3 equals y. The last step that I want to take here in finding the inverse is to write it in inverse notation. And what that's going to be is, instead of y, it's going to be f negative 1 of x. So that's just the inverse of x, negative 2x plus 3. The last step, and we're going to do this on the next slide, is to verify. Actually, that's not going to be the next step we're going to do. I'm going to show you a different method of finding inverses, and then we'll verify. But don't forget that verification piece is important. A second method to finding inverses has to do with thinking about what you would do if you were to plug a number in for x and evaluate. So if I plug a number in for x, the first thing I'm going to do is multiply it by 2. Sorry, negative 2. Once I get that, I'm going to add 6 to it. And finally, divide everything by 4. So then that's what I would do from top to bottom. Going backwards, I just think about what the inverse of each of those is. The inverse of multiplying by negative 2 is to divide by negative 2. Adding 6, the inverse is to subtract 6. And then opposite or inverse of dividing by 4 is to multiply by 4. And people tend to abbreviate these one way or another. You have to show me some steps for this. But basically what you're going to do is you're going to start with x, and then you're going to start at the bottom and go to the top. And these are your instructions. So if I have x and I multiply it by 4, then I've got the 4. My next step up is to subtract 6, so minus 6. And then my next step up is to divide by negative 2. So I divide everything there by negative 2. If I want to simplify that, I can do it like I did before, negative 2x plus 3. And there is my inverse function. The simplification piece is not necessary. I want to stress that. This, with the f negative 1x here, is perfectly fine. You don't need to move it to this step unless you're comfortable with it. So those are the two methods of finding inverses algebraically and simplifying them. All right, so the next part we need to do is verify it, and this is critical. You absolutely have to do this. So what we have here are the inverse function that we just found, as well as the original function that we started with. Now, I'm going to start with the inverse function in this particular case. You don't have to. You can start with the inverse and then, you can start with the original and then move to the inverse. What you're going to do is just pick a number. And this can be whatever. So I'm going to pick x equals 7. So what I'm going to do now is take 7 and I'm going to plug it into my inverse equation. And then I'm just going to evaluate. So, got negative 2 times 7 is negative 14 plus 3. Negative 14 plus 3 is negative 11. Then I'm going to take that outcome. That's my outcome. And I'm going to put it in for x into my other equation. So in this case, that's my original function. So f of, we'll go red, negative 11 equals negative 2 times negative 11 plus 6 over 4. Negative 2 times negative 11 is a positive 22 plus 6 divided by 4, which is 28, divided by 4, which is 7, which should match that number that you picked originally. So keep that process in mind. Pick a number, plug it into one of your equations, whatever you get out, plug into the other equation. You should get the number you picked to start with. Now, some things that can make this tricky. Zeros can throw this off. You have to make sure you pick numbers that are in the domain of x. So if you are dealing with a quadratic, you're going to want to pick something that won't make things weird in a square root. And that's, I don't know how to further explain that without causing issues. But just be careful that you're not using, I would stay away from negatives and zeros for sure. And sometimes other things come up that make it a little bit tricky. I'm going to take that. The other method of checking is by composite function. And this one is a highly proficient skill, I would call it. To get highly proficient, you have to be able to verify in both ways. So you have to be able to verify by putting a number in and then also by putting a value in. By putting the composite function, doing the composite function. So what I have here is the process of finding the inverse function for this original here. So I've got x plus 6 squared minus 4. What I'm going to do is I'm going to shrink that down a little bit. I'm going to do an inverse function. So what that is f of f negative 1 of x. So think about it this way. If I have just, say, f of 2, that means I'm going to plug 2 in to my equation for x. So what this is telling me, what this f negative 1 of x is telling me that I'm going to take my entire inverse, so this whole thing, and I'm going to put it in to x in my original function. So if I write out my original function, square root of, I'm going to make this a little long, x plus 4, and then minus 6. I'm taking out that x, and I'm plugging in my entire inverse function. So x plus 6 squared minus 4. Now, here's what you need to understand. If you use this method, or when you use this method, you have to show me every single step, because everything will cancel out here. It's very satisfying. So if you look at this first, negative 4 and positive 4, that's going to be the first thing to go. So what I have left is the square root of x plus 6 squared, minus 6. The next thing I have to deal with is the exponent. So that part can go next. Next thing I have, so the square and square root cancel each other out. So I've got x plus 6 minus 6. And that plus 6 and minus 6 gives me 0, and I'm left with x. This will always be the case. F of the inverse will give you x. The inverse of the function, so if I do this the opposite direction, f negative 1 of f of x, that will also give me x. That's always true if you've done your inverse correctly. Now the part where verifying is important and showing that this is what cancels this time, and this is what cancels this time, and this is what cancels this time, is you're showing me that you're actually checking. Prove to me that you checked it. Because if you skip from here to here, I'm not giving you credit for that. And it's very important that you understand that. So order of operations is pretty key. Make sure that you keep that in mind. So that is pretty much it. I'm going to reiterate that you have to show your steps. So you've got to show all of that verification piece. So that's it for finding inverses algebraically and verifying them. Have a lovely day.